Welcome to section 2.2. This story here in section 2.2 is about the inverse of a matrix. Now, some of you have perhaps seen this before and you know how to take the inverse of a matrix. Different methods for doing that that we'll discover in this video. I mean, it's going to be, I don't want it to be too long, but I want to show you why we do what we do in order to find the inverse. Now, there is a shortcut for a 2x2. Boom, boom, it involves just what we later call the determinant, but we're not going to do it that way. We're going to show it a different way instead. So I'm just going to play a game right now. What I want to do is I want to row reduce this into identity. Remember remember the identity matrix. That's mentioned in section 1. It plays the role of the number 1 in arithmetic, but in matrices, the identity matrix looks like this in a 2x2, and a 3x3, 4x4. You know what I'm talking about. Okay, so we're going to row reduce it. So let's take this guy. And I think the operation we'd want to have happen is, let's see, if I want to get it in identity form, I think I'll wipe out that 2 by going -2, row 1, add row 2. And of course, what happens there is exactly that. But before we do it, what I want to do instead is invent a matrix that will do the operation for us. Now, this is a good one. This is section 1.9 actually, a little bit, but it's kind of spinning off of that. When I multiply a matrix by identity, nothing happens, does it? It just simply goes 1, 0, -3, 0, 0, 2. In other words, it's kind of a code for what you want to do with that matrix. And the identity matrix, when I multiply, says, leave this matrix alone. But we can mess with this a little bit. If I go 1, 0 upstairs, let's start multiplying. Then it'll go times this, it'll go 1 and 0, okay, and -3 and 0, okay. So I'm leaving the top row alone. But here's how you make a change in the bottom row. In fact, I'm going to make this change in red. First, I'm going to erase the bottom row and everything else, I guess. Okay, and instead, I'm going to say, I want -2 row 1. So I'm going to put a -2 here, and I want it to add to 1 of the row 2. So -2, 1 does it. Try it. When you multiply this through, you get -2 and 2. Yep, that's what I wanted. And then the rest happens. This is 6 and -5 is 1. Let's call that matrix we just used, let's call this guy, if this is A, I'll call this E1, matrix E1, let's say. Wow, what a trip. I used a 2x2 matrix to do a row operation. Instead of me doing it, I multiplied by a special matrix to do that. Let's take the result that we have here, which is 1, -3, and 0, and 1. And the next move we're going to do is going to be 3, row 2, add row 1, I think, right? Won't that do the trick to wipe out the -3 above? And so if we do that, oh, wait, no. Instead, we're going to invent another matrix, and I think I'll call him E2, an E2 matrix to do the job. And so let's see, this time I'm going to want to leave row 2 alone. So I'm going to go no row 1 and 1 row 2. Watch us do the bottom. If I circle through this, I'll go 0 and 0, okay. And 0 and 1, okay. See, row 2 is preserved by using part of identity in that guy's row. But now we're going to make this other piece happen where it's going to be 3 row 2 added to row 1. So the first entry is row 1. I want 1 of those, and I want 3 of the row 2s. See how this is kind of going crazy? So let's do it. I'm going to go 1 and 0 is 1. And I'm going to go -3 and 3 is 0 when you go through these guys like that. So we did. We made it to identity. We've row reduced it. But here is, you ready? Here is the punch line. This is the punch line. When I take E1 and multiply A with it, and then when I'm done, I multiply it by E2, the math looks like that. So A, on the left, I'm going to multiply by E1, and then when I'm done, I'm going to multiply by E2, and if I put them all together, it looks like this, and what we got was identity. You know what that says about these two guys multiplied together? That's the inverse. Okay, so this means that E2 times E1 is A inverse because it's the matrix when you multiply them together. That's the matrix that when you multiply with A, you get identity. So that's the inverse of A. What does it look like? Let's look at it now. So what happens when we take E2 times E1? Let's see. E2 is 1, 3, 0, 1, and E1 is 1, 0, negative 2, 1. 1, 0, negative 2, 1. So do the product. That means you're going to do this stuff where you go, this guy is going to multiply with the columns here. So 1 and negative 6 is negative 5, and 0 and 3. And now we're going to go through with the bottom row, and it's going to be 0 and negative 2. And then it's going to be, what is that number there? I can't see it. Yeah, okay, 0 and 1. And this apparently is A inverse. Do you remember how to find the inverse of a matrix? If you take A, which is way up there now, it is 1, negative 3, 2, negative 5. And if you take his inverse, remember the trick? You're going to go 1 over the so-called determinant. It's going to be 1 times negative 5 is negative 5 minus a negative 6. And then remember what you do is you swap along the diagonal negative 5 and 1 and change the signs 3 and negative 2. And what we have outside is really just 1. All of this is just 1 over 1. So it's 1 and the matrix is negative 5. The inverse is this, 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 and this. And lo and behold, it matches, doesn't it? So it is the inverse. It is the inverse by that other axiom, okay? Now that's pretty wild. Now here's the thing, I want to end with this idea. It's going to take a little bit more time, but what we have is that E2 times E1 is equal to A inverse. And you know what A inverse is? It's the same as E2 times E1 times identity, because if you multiply by identity, nothing changes. But what this is saying is the same row ops that change A into identity also change identity into A inverse. And that's why when people look for the inverse of a matrix, what they do is someone says find A inverse, what they do is they put A here, which is 1, negative 3, 2, negative 5. They draw a line here and they put identity on this other side. And so what they do is they row up until you have identity on this side, and on the other side is A inverse. Because the row ops that change A into identity change the identity into A inverse. So let me write that here. This is A, this is identity, and over here A inverse. So this is how mainly how people find the inverse of any matrix, including 3 by 3, 4 by 4. The larger they get, the more insane that becomes. But at least we have a theory as to how this is done and why we do what we do. So that's an interesting look at how we find the inverse of a matrix. I hope you found much enjoyment in this, and happy studying.